that?
This thing? So much. Alright, let's try 19.2 number 1. So we want, we're given that f of x and y is 3x minus 5y. And then I realized that I didn't have an integral to perform, right? So at that point I went back and read the directions. Just maybe a little bit ass backwards, but whatever. And the directions say I should find dA for z is f of x and y oriented upwards. Okay, so I should remember that I have a bunch of forms for d area, right? With a vector kind of thought. The first one of these is just, okay, it's a normal vector times the regular scalar d area. What do I need to remember about that normal vector? Love the hair.
Yeah.
It's unit long, right? Okay, so if I could lay my hands on that, I'd be in good shape. Can I lay my hands on that from this f? Well, f's a plane, maybe, right?
Oh yeah, partial.
You guys see that? So I could find the normal vector for this plane and then scale it out to unit length. That would be one way I could do that. Another way I could do it is I could remember that there's a formula for when the surface you're talking about is a function. So in that case, f is given by the vector
Minus the partial of x,
Perfect.
I, minus the partial of y, j, plus k.
Yeah, so they're saying, right, that the normal vector in that case is something minus fx minus fy and 1. You guys see that? And this is a little bit weird, right? Because this area and that area probably feel a bit different. That kind of makes sense.
Wait, so is that? Yeah, negative fx, negative fy1. You can use that to get a normal, unit length normal vector for any function.
Yeah, you can use this to get the normal vector that'll go in here.
Yeah.
Yeah. So as long as the surface is a function, this thing will work.
So we can maybe use that in some of the earlier stuff too.
Yep. Yeah, so if you happen to have an equation for f, right, then this is a nice easy way to do it. Cool. So let me find this thing in terms of f. So I'm asking, hey, what's fx here?
3.
3. What's fy? Minus 5. Okay, so my d area, right, is
Vector negative 3, 5, 1,
3i minus 5j.
oops. I need a negative 3,
Oh, positive.
positive 5, and 1, the regular area. Cool. Check. Bam.
But what I didn't understand is when you multiply it with,
Oh yeah, so this is just finding the d area part,
Mhm.
right? If I'm going to actually execute this with a, right, if I'm going to actually execute a flux integral, right, I'm going to have the integral, oops, integral over my surface S of some vector field F dotted with this thing. Really, I'm going to do dot d area, right? And then I'm going to take this and I'm going to jam it in for d area. See that? So at that point, I need a vector realization for what f is. Yeah? And in that process, some of these bits might cancel,
okay.
right? Because I might dot product them with 0, or they might stick around depending on what the components of f look like. Cool?
Mhm.